we just gave grade 6 a chance to catch up. Because poor things, they've been behind like a slide or two all week long. So now, you guys are so kind.
We're just not good, Miss D.
Thanks for being so kind, aka very distracted on the phone. Hey, yeah, speaking of distraction, so Team DR is doing this little fundraiser Chick-fil-A night. You guys have been hearing it announced every morning since Wednesday. But today, well, I was selling Mrs. Johnson cookies, and then they all ran out. But Mr. Brache is giving me a whole platter of Brache bread. Money will go straight to our project. So if you guys want to buy Brache bread, bring your friends. Oh, the whole platter in here. You guys get to skip the line over there. Okay, infinite limits. Infinite limits, well, there are infinite limits, and then there are limits at infinity. They're similar, and yet so different. Because infinite limit means the answer somehow has an infinity in it. So this one, question, what would the limit be for this 1 over x squared that's been shifted somewhat horizontally and vertically? X is approaching c, that's true, but what's the limit of the function? Infinity. Why positive infinity? And the two sides are in, they're both approaching, aka an agreement. They agree, yeah? Okay, how about this guy? Negative infinity, because the both sides. The two sides coming from either side of x equals c, once again, is an agreement, and where are they headed? They are decreasing without bound, which means we say negative infinity. This one was increasing without bounds, so we say positive infinity, but what do we say here? However, reviewing yesterday, what would we say if we were talking about the limit as x approaches c from below x? The one-sided limit, how would we answer that? Positive infinity, because from the left, or from values below c, the function is increasing without bounds, so positive infinity. What would we say if we came from the other direction, the limit as, how do I show that coming from the right? Yeah, little c with a superscript of positive, f of x. Where is it headed? The function, I mean? Negative. So why did the limit not exist? And that's technically grammatically very wrong, but that's okay. Because the two sides do not agree. So the limit does not exist. But the limit does not exist.
Let's do a little back about English.
Okay. English teachers should have good math, and math teachers should have good English.
Good English.
It's not always true, though. If the limit as x approaches a is either, why are vertical asymptotes coming straight after, directly after infinite limits? Por qué, por quoi, how come?
Because
what
they
was
approach.
Here? What was here? What's here? One of those. So how do we know a vertical asymptote? As x approaches a, what's the limit approaching in any of these? Either positive infinity or negative infinity. So if the limit equals positive or negative infinity, there exists a vertical asymptote. And even though we're not to section 1.3 yet, you've done the summer packet for 1.3, and we got the whole factor and canceling, plugging in way better than this graph table thing. So can I go ahead and put a quick note, a quick aside a little bit early? This will always occur when solving limits algebraically by getting number over 0, aka infinite. Wait, I thought over 0 you keep going and you factor or you multiply by a conjugate or you simplify the complex fraction. Oh, it's not number over 0. Keep going goes with
0.
0 over 0. Number over 0. So be careful, just because it's over 0 doesn't mean we keep going, or doesn't mean it's a vertical asymptote. We have to check the numerator. And remember, what were vertical asymptotes called? What kind of discontinuities? I'm just giving you the word. What kind of discontinuities? There are holes and there are vertical asymptotes. They're both called discontinuities. The holes are given this adjective, whereas vertical asymptotes are given this adjective. Ah? The hole is removable because you can factor and cancel, reduce, canceling is the wrong word. Canceling goes to 0, reducing goes to 1. Yes, holes can be reduced out. They're removable. What are vertical asymptotes called?
Immovable.
Close. Let's make it a nice word though.
Immovable.
Not removable is 2 words. Let's make it 1 word.
Inremovable.
Non-removable. Oh, that was a good idea. Oh yeah, but it's still okay. But not removable is 2 distinct words. Non-removable is nice and flows. All right, discontinuity.
Unremovable.
Why is it non-removable? Because the factor is not shared. It doesn't have the same zeros like holes do. Anyway, the math should lead you to 0 over 0. That's a removable discontinuity. Shared zeros, shared factors. Anyway, that's the end of section 1.2. Boop. Homework. Let's double check that I have the title right for section 1. Oh, that's just an example. Oh, that's an example. Limits analytically. Yes, I have it right. Okay. Don't worry about the examples. That's extra stuff. We might have it as an opener one day. But for right now, homework number 2, evens. Here we go. Color pens out. Homework open. We're going to zoom through. Zoom, zoom, zoom. Wait for it. Number 22 is the first. Wait, didn't you guys have number 18? Where's my number 18? Oh no.
Hello.
He's there. He's just not showing up. Ah. Well, start with number 22 and 24, and I'll go find you 18. For some reason, he turned clear. That's weird. I apologize. Yeah, number 22, the limit does not exist. Number 24, the limit does not exist. Basically, they are approaching different limits, I do believe. What was number 18?
I got graph to find the limit.
Yeah, and it was secant, right? And then there's a yellow box down. What's going on? I don't understand.
What?
Oh well, number 26. You guys have a lot to grade.
Good morning.
All right, I'll just let you start playing with 26 as I get number 18 ready.
Wait, we didn't.
Miss D.
Yeah, we did. Oh, I didn't.
Miss D.
Awkward. Double check that one. Anybody else have something that they should show me? Wyatt? Oh, Wyatt's gone. He can't show me his textbook cover. Someone text Wyatt and tell him to send me an email with his covered textbook. Mariah, covered textbook? You're going to email me your covered textbook? Okay. Don't forget. Someone, who's texting Wyatt? Thanks, Kyle, about it.
I don't have his number, but I can text him on Hubble.
How do you?
On what?
Just think football. I don't know, something. Oh, you guys can see H, and that's the last one, I think. And H does not exist. The limit as x approaches 4. Okay. We'll come back to number 18 in a second. Do you guys realize that the answer key is not just giving the answers, but also the why? So if you're trying to correct your work, should you necessarily be writing every single thing down? No. If you were cheating from CalcChat, how does it look if you're writing down all these words when really just the answer is DME? Obvious. Not that I'm telling you how to cheat, I'm just saying. But anyway, if you do get it wrong, you can be looking to say, oh, wait a minute, hold on, I sketched this graph. What are they trying to say? Why does it not exist? So we'll go over questions in just 1 second. Number 30 was rough. So that's not the only answer. Maybe we should talk about 30. But that's one variation of the answer. That's one variation of the answer. I believe you had to have some sort of break here, some sort of non-existent limit at 2. Or it can be different. It can be different. It can be different. Maybe sketch theirs in parentheses and then ask me about yours in just a second. I think that would be a paint here as well. Oh, that would be a paint. Number 68 is false. Number 68 is false. I think that's the last one, right? Okay, I want you to see 30. I want you to see one variation, but long story short, I don't want you to keep staring at it because that was not the only way to go.
Okay, let's start back in at the beginning of homework. Are there any questions you guys want to see before 18, before the one that did not show? Anything before 18? Yeah, Pico. No. Okay, let's start at 18 then. Number 18, the one that did not show, says, use the graph to find the limit. The limit does not exist. Explain why. You are trying to go to 0 of secant, right? Oh, and they gave you a graph. Okay, so as you're approaching 0, question, what height, what y value, what function value is the function approaching? Got it. The limit exists, and the limit is 1. Why? Well, because they're in agreement as to where they're heading, and whether or not it's there doesn't matter. They're heading to 1. Oh, and it was there, and it was continuous at 1, which is nice. If you guys don't mind, I'm going to take a quick picture, because my answer key, well, my computer and my answer key, everything's mad at me this morning. Okay, what other question do we have for me to go to? Wow. Hi, computer. What's going on?
Good morning.
Wow. Nothing. Oh, there he goes. Now he's working. Okay, sorry. So I know where I'm headed. What's the next question? Vika, which one did you want to ask on? 27. Anything before 27 we need to go over? I'm just putting this picture in so next year, whether or not that shows up, I will have something to look at. Okay. Nope, nothing before 27? Okay. Number 27 gives us a piecewise function. Number 27 gives us a piecewise function. Oh, and it's a pink one. Did you guys watch the video?
Yeah.
What teacher was it? A good one or a bad one? It was a good one. Was it a girl or a guy? Nice. Not saying the guy's bad. I'm not discriminating. Just asking. Okay. So how did she explain what to do with a piecewise function limit? Because this one's weird. It just says like C. This guy? Okay. Right. Probably like making sure all the pieces matched up.
Yeah.
Because in the graphs that we were looking at, whenever the pieces don't match up, couldn't there be a problem? And what are the directions actually saying? How would you guys summarize? Some people write all the words, but who summarized it? What are they actually asking? Sketch. Okay. So the limit will always exist everywhere except for. Do you guys realize sometimes it's easier to answer where it doesn't work than to answer where it does work? So isn't the limit going to be totally fine everywhere except for where the graph breaks, right? Okay. So what we're looking for to answer where does the limit exist is basically saying, well, everywhere but here where the limit does not exist. So for x less than 2, we'll throw 2 there, and then we have a 4 here. We have an x squared. So isn't x squared going to be something like, hold on, where is x squared when x equals 2? 2 squared is 4. Okay, so let's stop this. Right? Oh, it's going to take away the whole thing. Yes, it is. 'Cause it's all like that. Oh, no. 2, 4. Sweet. Good? Where would this line be at 2? Because it's supposed to go everywhere up to 2, just not at 2.
4.
Yeah, because if you plug in, 2 times 2 is 4, and 8 minus 4 is 4. And then isn't this like a downwards facing line? Hold on, where would this be at 4? 8 minus 2 times 4 is 8. 8 minus 8 is 3.
Yeah.
So it's here, and it's here. But the awkward part, maybe it's a good thing, not an awkward thing. This one has a hole at 2, but this one has it filled in. So if we put the two pieces together, isn't it nice and filled in?
Yes.
Make sense? Because he fills it in, and then he says, okay, I'll keep going. But that one's open because not or equal to.
The lady said it was open.
The line's open. But this guy fills it in. Hold on, double check. 2 squared is 4, right? 2 squared is 4. This guy is 4. So technically the pieces are like this plus this plus this. And then you put them together. So this one actually lines up with that one. So the hole, do you see it? The hole goes over the filled in.
And then this one has major issues. So I put that piece on top of that. I don't know how she explained it. But the middle piece does have holes on either end, but the nice thing is it lines up right on top of that guy. And then this one, it doesn't line up at all. So question, are these all going to be good if I came together to any, or from any two separate directions from either side? Good, 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 good. When is it bad? So what's the one place the limit will not exist? So the limit does exist for all C not equal. These two pieces match up, so it's good because those two guys are headed to the same diner, but this one, no. So everything is fine except for here. The question was weird because it said, when is it good? And the answer was, well, find when it's bad and say not there. Kind of awkward. I'm sure the teacher taught it in a much more precise way. I did it in a quick, we're going over a homework question way. Watch the video. Okay, what else do we have? Do you want to go to that weird number 30? Where you got to, yeah. We guys had way different answers. Okay, number 30 basically says, make a graph where all these things are true. So let me tell you what had to be true, and then you guys could be creative from there. Let me tell you what had to be true. You guys could be creative from there. So, I knew at -2, because remember, f of x equals y. This is the x value, and this is the y value in an equation, right? So when x is -2, y had to be 0. I had to have this point. When x is 2, y had to be 0. I had to have that point. Now, other than that, I just needed, coming into this point, I needed both sides to be coming to 0, but there's a million different ways that could happen. I'll show you the funky one. Or if we were to do something like, and that comes into 0, and then we have something else being like, that coming into 0. I don't know. Then what? Oh, careful, he's not a function. He curved a little too much. I had a little too much fun. There you go. A parabola into a line. We can even make it funkier if you wanted. I think that's kind of what the book did. They said, I'm going to make it an obvious piecewise function. It's just going to break. And you're like, okay, you're weird. But what couldn't be true as I came into here? They couldn't meet. So whatever you wanted to do, somehow you had to have one piece come in one direction, and you could technically have nothing coming to that. You could have something else doing its own thing. Oh, nope, that's not a function. I can't have two filled in points. That doesn't work. But I could have done something funky with a hole and been like, ha ha ha. And then, I want a sine curve. I don't care. You do something. But the long story short is we needed a point there, in agreement coming to somehow, which could be super basic. It could have been a line. It could have just been a parabola. Somehow I just needed on either side coming in agreement to 0 for that one, and then somehow a break. Does that make sense? I appreciate you. Everyone else is just staring at me with no wiggle of the head, yes or no. Anybody who's like, I think I have one that's right, but I'm not sure, and you want to show me right now? If so, hold it up, facing me. You guys come together at a point and then go. Yeah.
Well, I just crossed it out, but I did that too.
Agreement, and then this. Yeah, totally cool. That's super basic, but it works. Yeah, Kyle.
So about the whole shaking, Mr. Hampton hates it when people say something. Is it, are we good to go? And we go, yes, he's like,
He waits like 30 seconds. He's like scared. It's like that's just a rule. Like you just have to wait until they say it. Like, okay.
He's trying to do the whole, yeah. He's trying to avoid people that answer quickly and break the learning process for people who can't process as quickly. You guys know that whole thing. However, I don't mind a this or this something because I work much faster than 30 seconds because calculus works much faster. And it's math, which is different than history. I'm not asking you a lot of like philosophical or what was right or wrong, compare, contrast. Okay, any other questions on homework? Sorry, we only made it up to 30. There was a lot more, but are you guys good or do you want me to pause somewhere? Ready for the quiz? Perfect. Just clear off the desk, but stay right there.
Wrong.
It's all about
Alright, section 1.3. Now, if you guys have looked in Google Classroom, when is section 1.3 due?
Someday next week.
Oh, maybe it just popped up this morning at 8 o'clock, and none of you have been looking at your phones, so you don't know. I'm so proud of you. Nicely done. It's due next Wednesday. You're welcome.
Oh.
Which means you have time, yeah?
Is it like 40? No, it's so far away.
Hi,
That
Adam.
means we have today, which I was expecting. You guys realize we have like 10 minutes left of class, right? Which theoretically, from the summer packet and from last year, for most of you, I probably could almost cover this in 10 minutes. But A, you wouldn't really have notes on it to refer back to, or example problems from my teaching. And B, not all of you did have pre-cal here last year. Or did have pre-cal with me. Mr. Che is great. Just, you're going to be stuck with me the rest of the year, so maybe I'll explain things a little bit differently. If I could switch places with him, probably would. That would double my commute. But he has like a similar tweet to me now. Speaking of, I told them about it.
Yeah. It's amazing.
You could even buy it now.
Remember to bring a sweater when I walk in.
First thing was so hot. What happened?
I know.
Wedding.
Yeah,
Your room is
okay.
Yeah, what? 60?
Notes are starting at the most basic of basic limits. Could you graph these guys to get their answers? The answer is yes.
Why would you?
I don't see a scrunchie. Okay, so.
Stop.
Dude, bro, stop. Me and these would be fun in this class, that's all I have to say.
Okay, what's the limit of any constant?
It's,
Wait, but we have to plug in two. There is a property that says the limit as x approaches any constant of a constant is constant. Which is why you guys were perfectly fine, because they drew a constant line. They drew y equals 0 for everything all the way up to 2, and then they popped up, they broke it, and went somewhere else. It was totally fine. Because the limit of any constant is itself. Because from either direction, you're facing the same one. But people get confused, especially when we start plugging in, because they're like, I don't know what to do. And they say like 2, or they say 6, or I don't even know what they do. But the long story short, there's no place to put the x. The graph is just a horizontal line. What height is any constant approaching? Itself. So you can memorize a property, or just realize, I go to plug in, and there's nothing there. Sweet, the answer is 3. We could memorize that the limit as x goes to c of any y equals x line is just going to be c, but we know how to plug in now, right, guys? So if we're doing this mathematically, analytically, algebraically, plug it in, plug it in. What's the limit as x goes to -4 of x? Just negative. And for any polynomial function, plug it in for. But actually, if you notice we're plugging in totally works for any continuous function. AKA, if you plug it in and it works, it's great. The only times you have to be careful is when you have a piecewise function. Because as you guys just noticed, if you plug into a piecewise and you plug into the appropriate piece based on the inequalities, pre-cal's doing that right now. How do you do f of 2 of a piecewise? We have to look at the inequalities and figure out where 2 is legal and plug into that piece. Limits aren't that easy because if the limits, do I still have that picture up? Oh wait, I closed it. Is it still here? If with a piecewise, for instance, if I was trying to do the limit, if I was trying to do the limit as x approaches 2 of f of x, why would I not just go to or equal to 2 and plug in and say 4? Haha. Why is that bad?
Make sure
A
it's
bad
for all
approach to
things.
the problem, even though the limit actually is 4, as we saw when we drew it. Sorry, Kyle, what were you saying?
It has to fit all of the criteria, right?
It doesn't have to fit all 3 pieces. Why just the first 2 pieces? A limit is not just about the at, the or equal to. It's a limit about the approach. So how or which pieces are coming in towards 2? Well, from below, isn't this piece coming in towards 2? Coming from above, isn't this piece coming in towards 2? So how could I answer that the limit is 4 for a piecewise function? Well, I would have to check out the pieces and say, okay, the limit as x approaches 2 from below, I better be looking at x squared. And the limit as x approaches 2 from above, I better be looking at 8 minus 2x. I need the below to agree with the above. So plugging in 2, I get 4. And plugging in 2, I get 4. So why can I say the limit is 4? The approaches agree. But how would I need to do the limit if instead of approaching 2, I was approaching 4? Oh, or equal to 4. Nice, 4. Done. Right or wrong? I don't know. We have to check. Don't we have to come from below? Which piece is below 4? For values below 4. 3.9, 3.5, 3. For those values right below 4 coming in, what piece? The second piece. Wouldn't 3.9 be here? Wouldn't 3.5 be here? Wouldn't 3.99999 be here? I'm plugging into this, right? How about if I'm coming from above 4? Which piece? 4.1, 4.01, 4.001. Okay. Limit of this guy is itself. What's the limit of this guy? Ooh, that's why the limit did not exist, and I didn't have to graph it. There's a way to do piecewise functions analytically. We just have to be careful when taking limits of piecewise functions, because these guys are fine. Look, they're happy functions. Plug it in, except I need limits towards or to the separators to be checked on either side. Anyway, piecewise functions are the one exception to this whole plug it in, where you have to be careful and not just go with plugging in. But otherwise, plugging in, if it works, the limit is done, and you've solved it. Technically, there are some snazzy limit properties. Most of these are fairly straightforward. However, the reason I'm giving you this, and guys, remember, you can shortcut, you can summarize. Limit properties. Don't even have to say the theorem. We never memorize things with like theorem numbers. Because different books number them differently. Just limit properties. B, comma, C, colon, real numbers. N, colon, positive int. F, comma, G, functions. Where this is true, and this is true. Because sometimes, especially with the AP, they love to give you clues. Like, hey, the limit is this, and the limit is this, and you don't even know what the functions are. So then they start manipulating the function. Multiplying by 2, or adding and subtracting, or multiplying, or dividing, or doing something weird with the power. Or maybe even far and beyond that. Asking you what the limit is, you have to be able to use not just the function, but also the limits, which is kind of weird. And they make it trickier different ways, but quick heads up is basically you can factor out a B, do a limit, and then solve. You can, in a sense, distribute limits with, careful, with functions. But you can distribute, in a sense. You can bring the limit into products. You can bring the limit into quotient. So limit of f over limit of g, as long as f and g are continuous, aka where g does not equal 0, because otherwise that would make it undefined. So we'd have to be careful and dig deeper if we did ever plug in 0. So this might seem silly. It might seem basic. But I promise there will be multiple choice problems at some point where you might get stuck because of this page. Basically, because of all these properties that you guys are writing down, when in your summer packet it was like plug it in, it's because technically we can change this problem to say, hey, x squared, yeah, he's fine. He has a limit as x approaches 2. 5x, yeah, he has a limit as x approaches 2. I can take it down to the basic, take it down to the basic, and take it down to the basic. Now, I'm going to never make you write all that. But when I'm having you just plug it in, it's because x squared, 5x, and 4 are all nice continuous functions where the limit exists as x approaches 2. But the shortcut is, oh, no big deal, it's 2 squared plus 5 times 2 plus 4, which you guys saw in your summer packet, which is 18. If I ever do a stupid math mistake, it's because I'm probably talking and writing at the same time. Super teachers. But I kind of have to do it as a teacher. Be gracious and be like, are you sure? Adam's got this one down from last year. So did a few others. The new kiddos, though, feel free, call me out. I don't mind. I do not pretend to be perfect in any way, shape, or form. Hopefully I'm at least a little bit better at math than you, but I've also been trained longer. So, long story short, does plugging in work?
Yeah.
Usually. We already said be careful of piecewise, and we'll see that more. From your summer packet, be careful of 0 over 0 and number over 0. One's keep going, and one is vertical asymptote. Check the sign of your infinities. But the nice thing is, kiddos, direct substitution is great. It's the first strategy you should always try to find the limit as x approaches c of f of x. Plug in c. And many times it will work. When? Always with a polynomial, because it's all real numbers. Always with a rational, as long as it doesn't make the bottom 0. Always with a radical, as long as it doesn't make the inside imaginary, or the whole thing imaginary. Always with composites, as long as it exists. Trig, as long as it exists. More transcendental. E to the x, ln of x, as long as it exists. So, plugging in is great. As long as it exists and is not piecewise. Now, could you guys keep going and do tons of homework this weekend? Totally. Summer packet, right? Do you have to?
No.
Nope, but you at least have to start. Bye, guys.